hypothesis testing, and all of our samples were just one sample. Now we're going to consider how you compare two samples, do hypothesis testing when we're comparing two samples. So the first thing we need to understand is whether these two samples are dependent or independent. Two samples are dependent if the members of one of the samples can be used to determine the members of the other sample. This includes matched pairs. So for example, dependent samples might be the same person before or after a drug trial. Before a drug trial would be their cholesterol level before a drug trial, would be sample 1. Their cholesterol level after the drug trial would be sample 2. But person 1 from sample 1 and person 1 from sample 2 are the same person before and after. Another way to pair things up is, let's say you did twins, or you paired up husbands and wives, right? So sample 1 is a husband, sample 2 is that husband's wife. Okay, so that in some way or another, these samples have been matched. Two samples are independent if the sample values are from one population are not related or any way paired or matched with the sample value selected from the other population. Type of hypothesis testing with two samples is we're going to look at the inferences that are about two proportions. So we have two proportions from two samples and they are independently selected. So we randomly select a sample from population 1, and we independently randomly select a sample from population 2. Now for each sample, the number of successes and the number of failures is both more than 5. This is really more of a requirement for the normal approximation, which your book covers the normal approximation, but Minitab does the exact value. So we're going to see that when we do use Minitab, we're going to we're not going to need this requirement. It's very similar to one sample. We're still going to have a null hypothesis and alternative hypothesis. The null hypothesis will include equality. So the null hypothesis will always be proportion 1 equals proportion 2, where my alternative will be proportion 1 is less than proportion 2, proportion 1 is greater than proportion 2, or proportion 1 is not equal to proportion 2. We're going to use Minitab to find the p-value, and we're going to use a pooled estimate for hypothesis testing, and we're going to do not use the pooled estimate for confidence intervals. In Minitab, under the options tab, it'll say you pool the estimates or consider the estimates separately. That's the not pooled. Then we're going to make decisions based on comparing alpha to the p-value using the same decision rules that we used before. If the p-value is less than or equal to alpha, the significance level, then we reject the null hypothesis. If the p-value is greater than alpha, which is the significance level, then we fail to reject the null hypothesis. These two sample proportion tests, we go to stat, basic stat, and below where we had all the one sample tests, you'll start seeing two sample tests, and you'll see one that says two sample proportion. You will enter in the appropriate data. Then under options, you're going to select pooled estimate if doing a hypothesis test, and you're going to select do not pool, or it says something about doing consider the estimate separately. That's what you do if you're doing confidence intervals. Then select the appropriate alternative hypothesis, either greater than, less than, or not equal to. So if we're going to do a confidence interval estimate of P1 minus P2, if the confidence interval does not contain 0, then we say that those two proportions are statistically significantly different. If 0 is contained in my confidence interval, then we say there is not enough evidence to suggest that the two proportions come from different populations. Otherwise, we cannot. Recall that we do not use pooled estimate for confidence intervals. Well, suppose we're going to look at two different methods for repairing a wrist injury. And one method will be a surgical remedy, and we have 67 successes out of 73 patients. And for a splint method, we had 60 successes out of 83 patients. We're going to test the hypothesis that the results are better with surgery than with wrist splinting. So our alternative hypothesis is going to be greater than. Because this is a hypothesis test, remember, we're going to use the pooled estimate. It is a drop-down menu on the options page. So when we do that, if you're doing the normal approximation, you're going to get a test statistic Z is equal to 3.12. The p-value is 0.001. The conclusion is p is less than alpha. Therefore, we reject the null hypothesis. There is enough evidence at the 0.05 significance level to say the results for the surgical group is better than for the splint group. Confidence interval, we're going to construct a 90% confidence interval. Since we're now doing a confidence interval, we do not use the pooled estimate for p. We're going to change the alternative to not equal to. I've made that adjustment even though our original test was a greater than, and I made that adjustment when I changed the confidence interval to 90% instead of 95%, which would have been a 1 minus alpha. The 90% confidence interval came out to be 0.0983474, 0.291486. 0 is not in this interval, so we came to the same conclusion. We reject the null hypothesis. There is enough evidence to suggest that these two proportions come from different populations. Next, we're going to look at inferences about two means with independent samples. The two samples must be chosen independently of each other. So I'm randomly going to select a group for sample 1, and then I'm going to close my eyes and randomly select a group for sample 2. Both samples have to be simple random samples, and either both samples are bigger than 30 or both samples come from populations with normal distributions. First, either the two population standard deviations are known. Then we use a normal distribution, or if it can be assumed that the two standard deviations are equal to each other, not necessarily known, but they're known to be equal to each other, then we can use a t-distribution with the pooled standard error. There's a place on the options page that says assume equal variances, and you check it if you can assume equal variances. Otherwise, you use the t-distribution for an approximation. Note, number 1 is very rare and is not even dealt with by Minitab or probably with almost any statistical software. But with this two-sample t-distribution, we're going to have a box to check that says assume equal variances or not, and you only assume the equal variances if you know that they are definitely equal to each other. If you do not know, if you're not explicitly told that, then do not check that box. Basic stat, two-sample t. You enter in the appropriate data. If the two population variances are known to be equal to each other, then you check the appropriate box, otherwise you leave it unchecked. And then you select the appropriate alternative hypothesis, either greater than, less than. So we're saying mu1 is greater than mu2, mu1 is less than mu2, or mu1 is not equal to mu2. And the null hypothesis will always be mu1 equals mu2. So here's an example. The example is on page 409 of your text. So I'm going to enter in the smokers data. N is 40, X bar is 172.5, and the standard deviation for the smokers is 119.5. Then we're going to enter in the data for the non-smokers. N is again 40, X bar is 60.6, and the sample standard deviation is 138.1. We're going to test the claim that the smokers have higher levels of cotinine than non-smokers exposed to smoke. So we're doing a greater than. Smokers we're going to let smokers be sample 1. So we think mu1 is greater than mu2. So our alternative is greater than. The test statistic being 3.88, The p-value is 0. P is certainly less than alpha, so we reject the null hypothesis. There is enough evidence at the 0.05 significance level to say that the cotinine level is greater for smokers. Next, we're going to look at when we're dealing with matched pairs. Remember, matched pairs are the same person before and after, or somehow or another we've matched these pairs together. The samples need to be simple random sample, and either both samples are bigger than 30 or both samples come from populations that are known to be normally distributed. Now, our hypotheses are based on MUD, the mean of the difference. Minitab will calculate this difference for us, so we don't necessarily have to do it for ourselves. To use Minitab, you're going to enter the data into two different columns. Column 1 will be sample 1, column 2 will be sample 2. Then you go to stat, basic stat, paired T. Paired T is the same thing as with the two sample matched pairs. Then you go to options, you enter in the two columns that you have your data in, go to options and select the appropriate alternative. Well, suppose I have, this is example 1 on page 420 of the text. I'm going to enter temperatures that are taken at 8 a.m. and I'm going to enter temperatures in column 2 that were taken at noon, or I think it's 12 a.m. in fact, 12 a.m. and 8 a.m. Now I'm going to, now notice you have to have the exact same number. I have 1, 2, 3, 4, 5 pieces of data for both samples because it could not be matched if not. So 98 is person 1's temperature at 8 a.m. That same person's temperature at 12 a.m. is 97. Patient 2, his temperature at 8 a.m. is 97.6. His temperature at 12 a.m. is 98.8. So these are the same people where their temperatures are taken at different times. We want to test the claim that there is just a difference between these two temperatures, which means my alternative hypothesis is not equal to. Mu1 is not equal to mu2. Put this information in and click OK. My test statistic is T is equal to negative 1.11. The p-value is 0.328, which is certainly greater than my significance level of 0.05, which means I failed to reject the null hypothesis. There is not enough evidence at the 5% significance level to say there is a difference between these temperatures. The last one we're going to look at is comparing variation between two samples. And the two populations need to be independent of each other. The two populations must each be normally distributed. When we did the one sample variance test, we used a distribution known as the chi-square distribution. The F distribution is similar to it in that it is also skewed right and it is also positive. So the F distribution is not symmetric, it's skewed right. All values are positive, and it takes on a shape which depends on two different degrees of freedom. The large values of F are evidence against the null hypothesis. Two variance hypothesis test to test whether two variances come from the same population. We're going to enter the appropriate data. You use the data entered in a column, or you can use the sample variance, or you can use the sample standard deviation. Then you go to options, select the appropriate alternative hypothesis. Let's look at example 1 from page 430 in the text. We're going to compare the standard deviation of IQ from a group of low weight births and normal weight births. So what we're trying to see is there more variability in the IQ scores from low weight versus normal weight? So let's enter the data in. I have N is 258, the mean is 95.5, and the standard deviation is 16. For the normal weight, I have N is 220, the mean is 104.9, and the standard deviation is 14.1. We're going to test the claim that the standard deviations from the two groups is different, which means when we go to the alternative, our alternative hypothesis is not equal to. Back our test, we get that the test statistic is F, which is 1.29. My p-value is 0.054. I know it's not a lot bigger than the 0.05, but it is still greater than 0.05. So we fail to reject the null hypothesis. There is not enough evidence to suggest that the two groups have different standard deviations. That's the end of chapter 9. Now it's time to go do the assignments in my Math Lab website. There'll be several assignments, one for each section. Then watch the lecture recording for Minitab Lab 9. Download Minitab Lab 9, complete the lab, follow the normal instructions of either typing in your answers and saving as a Word document, or handwriting your answers and scanning and save as a PDF, and then you upload them to coursework on the portal. Please let me know if you have any questions whatsoever, and on either the homework from my Math Lab or any of the labs. Thank you.